All right, today we're creating a field guide to geometric shapes. Let's dive right in.
So they might look pretty different, but believe it or not, they're all playing by the same set of rules. They're all part of a big family called polygons, which is really just a fancy way of saying closed shapes with straight sides. And here's the secret code for them. This formula finds the sum of their inside angles, where n is just the number of sides. And this formula is super powerful. You can use it to figure out how many sides a shape has. Now let's zoom in on one popular branch of this family tree, the quadrilaterals. So meet the quadrilateral. To put it simply, it's any polygon with exactly 4 sides. And here is the magic number. Their interior angles always add up to 360 degrees, every time. Now, inside this group, one member is kind of the star of the show, the parallelogram. So what's its deal? Well, it just has 2 pairs of parallel sides. Simple as that. But that one simple rule gives it some really useful properties, which help us identify other shapes. Okay, this is where it gets interesting. What happens when we add a special condition? You get a rectangle, a specialist shape that's all about those perfect 90-degree angles.
All right, let's rewind. What if we tried a different rule and made all the sides equal instead?
That gives us a rhombus. It's a parallelogram where every single side is the same length.
So what's the ultimate specialist? The one with right angles and equal sides.
You get the square. It's basically a rectangle and a rhombus all rolled into one. And this chart breaks it all down. You can see how the square literally inherits traits from both. So why does any of this matter? Well, let's use these rules to solve a little puzzle. Here's our challenge. We need to find the missing values in this parallelogram. By just applying our rules, step by step, we can totally crack this thing. See, just knowing the properties of a parallelogram gives us all the clues we need to solve it. Every shape has its own logic. The real question is, what will you explore next?